Hey everyone, welcome. Today we're diving into a super powerful tool for your calculus toolkit, logarithmic differentiation. This is the secret weapon you pull out when you're staring at a derivative that just looks, well, impossible. So if you've ever been totally stumped by a function that has variables in both the base and the exponent, then you've come to the right place.
So, here's our game plan. First, we're going to see exactly why our normal rules just completely fall apart. Then, I'll give you a simple four-step strategy to knock out any of these problems. We'll walk through the classic example, level up with some tougher stuff, and then wrap it all up with the big takeaway. Let's get right into it.
Okay, so first up, Section 1, when the rules break. This is all about understanding the core problem. What on earth do you do when a function just refuses to play by the rules you've spent so much time learning?
All right, here it is, the classic calculus head-scratcher. Y equals x to the power of x. Just take a second and look at it. What rule would you even try to use here? It kind of feels like a trick question, right? And, well, in a way, it is.
And this is the heart of the problem. You've got the power rule, but that needs a constant exponent, which we don't have. Then you've got the exponential rule, but that needs a constant base, which, nope, don't have that either. Our function has a variable in both the top and the bottom. It literally breaks our two most important rules, which means we need a whole new game plan.
So that leads us right into Section 2, the logarithm strategy. And listen, we're not going to get lost in some dense, complicated theory. Instead, I'm just going to give you a simple, four-step plan that works every single time.
You know, this quote right here really nails why this whole strategy is so amazing. Logarithms are basically your best friend in calculus. They have this incredible power to simplify things before you have to do the hard work. They take these scary-looking powers and messy fractions and just turn them into simple addition and multiplication. It makes our job way, way easier.
So here it is. This is your toolkit. Really just four simple steps. 1. You take the natural log of both sides. 2. You use your log properties to break it down and simplify. 3. You differentiate implicitly. And 4. You solve for y prime. That's it. That's the whole strategy.
All right, enough talk. Let's put this plan into action. Section 3, solving the classic case. We're going to take on that original problem, y equals x to the x.
Okay, let's do this. We're actually knocking out the first two steps right here. Step 1, we take the natural log of both sides. That gives us ln of y equals ln of x to the x. Then, step 2, we simplify using our log properties. And this is the magic trick right here. That exponent x just comes down in front. Suddenly, our equation is ln of y equals x times ln of x. See? So much better.
Okay, next up, step 3, we differentiate. Now on the left side, the derivative of ln of y is going to be 1 over y times y prime. And on the right, what do we have? It's a classic product rule problem, right? The first term, x, times the derivative of the second, plus the second term, ln of x, times the derivative of the first. So after all that, what do we end up with? The left side, easy enough. That becomes y prime over y. Now the right side, it cleans up really nicely. The derivative of x is just 1, so that's 1 times ln of x, and then x times the derivative of ln of x. Well, that's x times 1 over x, which is just 1. So we're left with ln of x plus 1. Simple.
We are on the home stretch. This is the beginning of our final step. Step 4, solve for y prime. And to get y prime all by itself, all we got to do is multiply both sides by y. That leaves us with y prime equals y times the whole quantity of ln of x plus 1.
And this is the final, super important part of step 4. Don't forget this. You can't leave that y just hanging out in your final answer. You have to substitute back. What was y to begin with? It was x to the x. So we swap that back in, and we get our beautiful final answer. The derivative is x to the x times the quantity ln of x plus 1. We did it. Okay, so you've seen the basics. Now it's time to level up. Section 4, level up your skills. Let's see how this awesome four-step process handles functions that look even more intimidating. All right, how about this one? Y equals x to the power of sine of x. Again, you've got a variable in the base, variable in the exponent. Yeah, that looks kind of nasty, but guess what? We have a plan, and that plan's going to work just fine. And would you look at that? The process is exactly the same. We take the log, which lets us bring the sine of x down in front. We use the product rule to differentiate the right side, then we solve for y prime and plug the original function right back in. The core strategy doesn't care how complicated the pieces are. It just works.
But here's the cool thing. This isn't just a one-trick pony for weird exponents. It's also an incredible tool for simplification. Let's check out a totally different kind of problem where this strategy is an absolute lifesaver.
Just look at this thing. Seriously, can you imagine trying to differentiate this with the quotient rule, and you'd have to use the product rule inside of it? Ugh, you'd be at it all day, and trust me, you'd probably make a typo somewhere. There's gotta be a better way.
And boom! This is where our strategy is just a lifesaver. We just take the natural log of both sides, and the log properties completely tear this problem apart for us. Multiplication becomes addition, division becomes subtraction, and all those powers and roots, they're just simple numbers out in front. That monster of a fraction just turned into a simple line of addition and subtraction. I mean, look at that. How much easier is that to deal with?
And now differentiating this? It's like night and day. Instead of that quotient rule nightmare, we're just zipping through, taking a few really simple derivatives, one term at a time. This is the real power of simplifying your problem before you even start calculus.
So, the final move is exactly what we've been doing. We just multiply that whole result by the original function y. It's a clear pattern. The answer is always the original function times the derivative of its natural log. All right, that brings us to our final section, the takeaway. Let's do a quick recap of what we've learned and why this is such a crucial skill for you to have on your calculus journey.
So, let's wrap this up. What are the big takeaways? Number 1. Logarithmic differentiation is your go-to move when you see variables in both the base and the exponent. Number 2. It's your secret weapon for making messy products and fractions way easier to handle. And number 3, it all boils down to that simple 4-step process. Log, simplify, differentiate, solve. Master that, and you're golden.
So I'll leave you with a question to think about. Now that you have this method, this new tool in your arsenal, what other problems that looked totally impossible before are suddenly solvable? This isn't just about learning one trick. You've basically unlocked a whole new level of calculus problems you can now take on.